In our previous lecture, we did talk about testing the hypothesis based on the p-value. To be able to understand it better, we are going through an example and then explain different type of the gathering p-value or calculating p-value in different situations. In this example, let's say we have 30 students who participated in a statistical course in 3 different days. And in the beginning of each day, a questionnaire just introduced to them, and it measures their fear of the statistic at the start of each day. And we are going to record this and put it in the SPSS under the different variables like fear of a statistic as FOST1, FOST2, FOST3 for day 1, day 2, and day 3. And because we measure the fear based on this scale, it's a continuous variable. And in the last day also the students evaluate the course as a bad, good, and excellent. And also we recorded on the variable named lectures. I put those names because we use some data later that is available, and they are under those names under lectures as the categorical variable with 3 subgroups as bad, good, and excellent. We made 3 questions that we're supposed to answer. The question number 1, is there any significant difference between men and women for fear of statistics in day 1? And the second question is we want to answer, does the participation of the course has an impact on the participants' fear of statistics after 3 days or not, which we actually compare fear of statistics in day 1 and day 3. And the last question we are going to answer is for variable evaluation of lectures, as you see here with bad, good, and excellent. Is there any difference regarding fear of statistics in first day or not? So fear of statistic in first day. When you look at these questions, you can also make the null hypothesis. For the first question, the null hypothesis will be there is no significant difference between men and women for fear of statistics in day 1. And every time you have the null hypothesis, you should define the involved variable in this question. Here we have, for example, gender, male and female, a dichotomous nominal variable as male and female, and also we have the fear of a statistic as a continuous variable. For the question number 2, the null hypothesis, there is no significant difference between day 1 and day 3. And also the involved variable will be day 1 versus day 3. So we have 2 categories, one day 1 and day 3, which is dichotomous categorical. And you have also fear of a statistic in 2 different days, which is the continuous variables that we want to compare fear of statistics day 1 with the fear of statistics in the day 3. And this third question here, we have the null hypothesis as there is no significant difference between 3 subgroups of lectures, which is bad, the people who evaluate the lecture is bad, the people who evaluate lecture as good, and the people who evaluate the lecture as excellent. We made 3 different groups, and we want to also check the fear of a statistic in these 3 different groups. So the involved variable will be the variable lectures and the variable FOST1. Okay, let's go and do the question number 1. The first thing that you see, we divided the participant into 2 groups, and these groups are independent regarding the fear of a statistic. Means fear of a statistic in women is not dependent to fear of a statistic in men. This is absolutely independent. So we have 2 independent groups, and we are measuring a continuous variable between these 2 groups. So we have one dichotomous and categorical variable, and we have one continuous variable. In this case, we are using a test called independent t-test. Independent because there are 2 independent groups. and we are reaching to the p-value to answer our question and accepting or rejecting the null hypothesis. When we choose a test generally to analyze the data, part of the process involves checking assumptions that are required for a valid results. For independent t-tests, there are six different assumptions that we should keep in mind. The assumption number one is your dependent variable should be measured on a continuous scale. It can be interval or ratio level also. Here we have the scale here as the fear of a statistic. This is our dependent variable. So the assumption number one is okay. The assumption number two, your independent variable should consist of two categorical independent groups that we have it as male and female. And the assumption number three says that you should have independent of observation, which means that there is no relationship between the observations in each group or between the group themselves, which is we are just give them a questionnaire and we have this assumption also. Assumption number four mentions there should be no significant outliers. Outliers are simply single data points within our data that do not follow the usual pattern. They are even too extreme in the less or too many. The problem with outliers is that they can have a negative effect on the independent t-test, reducing the validity of our results. Fortunately, when we're using SPSS statistics to run the independent t-test, we can easily detect the possible outliers. Assumption number five says that your dependent variable should be approximately normally distributed for each group of the independent variable. And when we say approximately normally distributed, this assumption for independent t-tests only required not completely but approximately normal data, because it's quite robust to violation of normality, meaning that this assumption can be a little violated and still provide valid results. You can test for normality using also another test called Shapiro-Wilk, for example, which is also available in the SPSS. And we can just explain later. The last assumption is there needs to be homogeneity of variance. And this assumption 6 is something that we need this test of homogeneity, and we can test this assumption in SPSS using the 11th test. And then I will explain it when we do the test there. You can check assumption number 4, 5, and 6 using the SPSS. Before doing this, you should make sure that you have assumption number 1, 2, and 3. Also, you don't need SPSS statistic to do assumption number 1, 2, and 3. So let's see what we should do in the SPSS. In SPSS, we are going to click Analyze, and then we choose Compare Means, Independent Sample T-Tests, and then you will be presented when you click in this one with a dialog box like this one, Independent Sample T-Test, and you can transfer the dependent variable into the t-test variables, as you see, and you have it here, t-test variables, and here are the test variable here is the fear of the statistics that we can add there, and also the grouping variable box we can add the how we group. This is based on gender. The name of variable is sex here. Here we need to define the groups, and we define the genders as 1 and 2. So if you click on the define groups, we can just say group 1 as 1, group 2 as 2. Sometimes we have more than subgroups and we want to do only between 2 of those groups, so we can use the independent t-test there also. Remember that independent t-test, one of the assumption is a dichotomous categorical variable. And when we add them, we can also click the OK, and the SPSS will give us the results. Well, SPSS generates two main tables of output for the independent t-test. First table provides useful description statistics for two groups that we are comparing, including the mean here, and as you see, and the standard deviation. As you see, the fear of a statistic in the male is 41.2 and in the female is 39.13, which shows that the fear of a statistic in the first day is higher than the female, with the difference around 2 in the scale. And then this one has the different also standard deviation, but still we can see the difference, but we cannot say if it's significant or not. By looking the second table, we actually have the actual results here in the independent sample t-test here that we have. Well, to be able to read it correctly, by looking at the Leven's test first here, as you see, Leven's test, we can read the Leven's test first. And here the Leven's test has a level of significance that this is not the result that we are reporting. We use it only to find out which result we should read here, the significant two-tailed, the first line or the second line. In case that the Levin test is more than 0.05, we are going to read the first line. And if the Levin test was less than 0.05, which is not here, we are going to read the second line. Because we have 0.16 and this is greater than 0.05, we are going to report 0.28 as their p-value for comparing male and female fear of a statistic in the first day, and we can report it in our paper or in our article that the study found statistically no significant difference between men and women, and at that point we can also put the mean and the standard deviation of both genders, and also there was no significant difference in fear of a statistic in the first day, and reporting the p-value here also.